Hello everyone, so welcome to my playlist on multiple integration. So the agenda for today's session is we will talk about cylindrical coordinate system, then we will see pictorially, then we will see the setup, how does it looks like, then we will see why the name cylindrical, then we will see what is R. Usually the people have misconception about R, so I will make sure that gets clarified today, and then some examples. So how if the equation is given in cylindrical form, how to convert into Cartesian and how to sketch the figure, and then again how to solve in cylindrical coordinate system, and then we will see how to play with examples where the change of order has been asked. Okay, so change of order is partially, you can say, kind of easy in Cartesian coordinate system. Here you have to be little bit careful, so I will take one example for this as well. Okay, so let's go for the first point. Now what is cylindrical coordinate system? Now it's, you can say, kind of a extension of polar coordinate system. So in double integration you have seen that if you have x comma y, then correspondingly you have r comma theta. This is in Cartesian coordinate system, this is in polar coordinate system. What you do in triple integration, now here you have x comma y comma z, one more variable, the third dimension. Correspondingly you keep r theta as it is with respect for x and y, and you keep your z as it is over here. So this is how a triplet in Cartesian coordinate system looks like, and this is how a triplet in cylindrical coordinate system looks like. Okay, r theta and z. Now question is this a unique representation? Answer is no, as we saw here as well in our, I think, 9th or 10th lecture, that r can be positive, negative, and theta, I mean, since you have sine and cosine in the picture and they are periodic, so they will keep on taking the same value after the interval of 2 pi. So here also the same thing. So the representation is not unique, but if you want to make the representation unique, what we do is we keep r to be positive and we take theta to 0 comma 2 pi. So if you keep this as the restriction, then given x comma y comma z, you have a unique r comma theta comma z, and given r comma theta comma z, you have unique x comma y comma z here as well. So this is a one-to-one correspondence. One-to-one is it, given a point you have a unique point over here, given a point you have a unique point over here. So it's a one-to-one mapping. So this is how a triplet in cylindrical coordinate system looks like. Okay, now let's go for the second point, pictorially. So what I want to say is pictorially means what? How does a point looks like over here? So you have x, y, z, and you take any point P, which is nothing but my x comma y comma z, and when you project this on xy plane, this is your x comma y, because your z is 0 in xy plane. Okay, now here if I want to call this as, if I want to find what is the corresponding r theta z, so z is the same thing. What is your z? It is the height over here. So this quantity is your height, the z, which is same here as well as here. Now how will you find r and theta? You project this over here, which we already did, and for this x comma y, how do we find r and theta? You take its distance from origin, which is my r, and what is the theta? It is the angle made in anti-clockwise direction with respect to positive x-axis. So this is how you find r, this is how you find theta, and z is already given to you. So given x comma y comma z, this is how you find your r theta and z. Okay, now what is the relation? That's the third point, the setup. For that one should know the transformation. Okay, so the transformation is the same thing as you saw for the polar coordinate system. So you replace your x by what? So the third point is you replace your x by r cos theta, the same thing. You replace your y by r sin theta, and you are keeping your z to be same as z. Okay, there is no change in z. So this is the transformation we do, and therefore your dv, which is nothing but dx dy dz or dy dz dx, any of the 6 possibilities, that get converted to what? Since there is no change in z, so dz remains as it is. What about dx dy? We know that by polar coordinates, this is nothing but r dr d theta. So whenever you replace your dx dy, whenever you are doing this transformation from Cartesian to cylindrical, this is what you do the substitution, and for this dv, this is what the substitution you do. Okay, so keep this substitution in mind. Okay, so in general, how does integration will look like? You will have some region, say r, your function now will be in terms of r, theta and z, and then you have dz, dr, d theta. So this is how a problem in cylindrical coordinate system looks like. I mean, when you are solving using cylindrical coordinate system. And suppose if someone is asking you to find the volume, then we know that triple integration of 1 gives me the volume of R. So if I want to replace that 1 dot dv, that will be replaced by R dz dr d theta. What is this? This is nothing but the volume of the surface R, which is in 3-dimensional space. Now let's come to the fourth point. Why the name cylindrical? Okay, now see, we know the relation between xy and r theta. What is the relation? If I do the squaring and adding of x and y, I get r square. And what is my tan theta? It is nothing but y by x. When I divide y upon x, r gets cancelled, I have tan theta. And z is as it is z. There is no relation of z with r and theta. So this is what the relation we have. Now see, whenever I give a triplet, say if I give you r comma theta comma z is equal to say 2 comma pi by 4 comma 3. That means r is 2, theta is pi by 4, z equal to 3. Now how will you plot this point? Now as soon as I give you r equal to 2, what do I have from this relation? We have that x square plus y square is equal to 4. But what is x square plus y square equal to 4? In 2-dimensional plane, it's a circle. But when we are in 3-dimensional space, suppose this is my origin over here in between. This is the origin we have. Now what you do? This is the origin you have in between. You draw a circle of radius 2, right? Now once we are in 3-dimensional space, what you do? You lift the circle up, you pull the circle down. The same thing we saw in our last lecture, right? So the circle which was in 2-dimensional space becomes what? It's a cylinder in 3-dimensional space. And that's why the name cylindrical, because we are getting the cylinder. Okay, now given this triplet, will we get a unique point? Answer is yes. How do we get that? So this middle point was my origin. Okay, you draw the circle of radius 2 and you are getting the cylinder. So R is giving me the cylinder. So the point is somewhere on the cylinder. Now where is that point? Now use the second thing, theta equal to pi by 4. So now this was the origin. This is my positive x-axis. With this positive x-axis, you are making an angle of pi by 4, 45 degree. You make an angle of pi by 4. So you have this ray over here. You have this plane, you can say, over here. Okay, so from 0 you make a pi by 4, you get a plane. You already are having a cylinder over here. You are already having a cylinder over here and you are cutting it with this plane. So this curved part over here is getting cut with a plane. So what is the intersection? The intersection is this line over here, right? And now as soon as I give you z equal to 3, you take z equal to 3 plane. So what is the intersection of a plane and the line? It is nothing but a point. That point is nothing but this point. I hope this is clear. If this is not clear, you can go to the setting and you can reduce the speed and you can watch it again. Okay, so that's how you represent a point. Okay, like how do you draw the point in xyz? If I give you say 1, 2, 3, you draw x equal to 1 plane. Okay, so if this is my origin over here, x-axis, y-axis, z-axis, you draw x equal to 1. Suppose this is 1. You draw x equal to 1 plane. Then you draw y equal to 2 plane. So this is y equal to 2 plane. So this is 1 plane. This is another plane. What is the intersection? This line over here. Right? And what is z equal to 3? This is z equal to 3. So intersection of a plane and the line is nothing but that point 1, 2, 3. So this is the intersection of 3 planes. This is the intersection of a cylinder, the angular plane and z equal to 3 plane. So that's how you plot a point. So yeah, so this was one important thing which one should realize, how to plot a point. Okay, so that was one thing. Now one last point, what is R? Okay, R is distance of a point from origin, but that is in 2-dimensional space, not in 3-dimensional space. Okay, so if you are in 2-dimensional space, you have a circle, you take a point say P, which is x comma y, then yes, this distance is R, okay, which is nothing but square root of x square plus y square. Now suppose if you have a cylinder, okay, so suppose you have a cylinder over here and you take a point P on the cylinder, P, which is nothing but x comma y comma z. This is y, this is z, this is x. Is this distance from origin, is that distance R? No. Why? Because what is your r? R is square root of x square plus y square. And what is this distance from origin? This is nothing but the distance is root of x square plus y square plus z square. Let me call that as suppose say rho. So this is rho I am calling. So rho is what? It is the distance of a point P from origin, which is root of this. And obviously this is not equal to r. So r is the distance of a point from origin in 2-dimensional space but not in 3-dimensional space. So if you take any point on the cylinder, this is rho, which is not equal to r. Good. Now question is, what is r then? See, if you are in here in xy plane, if you are in xy plane over here, then okay, this distance is r, right? This distance is r. Now once I give you suppose z equal to 3, so you cut your cylinder which says z equal to 3 plane. So you have some plane over here and you cut it with z equal to 3 plane. So what is the, so you have a cylinder, you are cutting it with a plane. What is the intersection? It's a circle. So you have a circle over here. You have a circle over here and with this as the origin at height 3. Then this is what my r is, because it's the distance from origin, right? So you ignore your z, so this, because z is fixed now, right? Here in xy plane your z is 0, so here your z is 3 fixed. So now this is the distance r from origin. From origin means from this as the center, not origin. So this is my r. So if you take a plane over here, you get a circle over here, intersection, this is my r. So what is your r? Keep this in mind. So if you take a point on xy on that cylinder, so it is a distance of a point P on the cylinder. It is the distance between, I will say, it is the distance between a point on the cylinder and the axis of cylinder As you can see, the cylinder is symmetric about z axis. So here the axis of cylinder is z axis. And what is this? This is your r. So r is not a distance from origin. It is the distance, if you are taking a point on the cylinder, it is the distance between the point on the cylinder and the axis of the cylinder. If you are having like this wala cylinder over here, then this will be your r, because in that case your z axis, your y axis is the axis of cylinder. Okay, so make sure the notion of r is clear. This will help you when you are playing with change of order. Okay, so yeah, so these are some points which one should be clear with when they are playing with cylindrical coordinate system. Okay, now let's go for examples. So here is the first example. You need to find the volume of the surface bounded by r equal to 2 sin theta, that is the base bottom, and from the top it is bounded by this plane. So I want to find the volume between these two surfaces, or these two regions, I will say. Now to first of all to solve this, I should know what is the formula for volume. So triple integration. Whenever something is given here in terms of polar and z is there, you will go by a cylindrical coordinate system. Or suppose whenever you see cylinder as a word in the question, or you will see the circle, or whenever the arc things comes into picture, you prefer cylindrical coordinate system. But there is one more thing, which is a spherical coordinate system. So when sphere comes into picture, we will play with spherical coordinate system. That we will see later. So okay, so this is one thing. Now I want to find the volume of the region R. Since I want to find volume, R, dz, dr, d theta. So no need to worry about the integrand. Only thing is, what are the limits? But for limits, you should know what is the region. But here, I don't know what is this region looks like. So what you do is, you convert that into Cartesian coordinate system. So what you have, r equal to 2 sin theta. But what is my sin theta? Y upon r, because your y is r sin theta. So this is your r square equal to 2y. So what is r square? X square plus y square equal to 2y. You take 2y on the left hand side. And now if you do the completion of square, so y square minus 2y, if I do plus 1 and 1 both side, completion of square, half into coefficient of y the whole square. Right, so by that method I am getting 1 over here. So I have x square plus y minus 1 whole square equal to 1. So I am having a circle with what is the center 0, 1, and what is the radius 1. So therefore the center is lying on y axis and the radius is 1. And top is what? Top is this plane. Okay, so let me try to draw the figure over here. So you have x, y, z axis. So now you have a circle with center 0 comma 1 and the radius is 1. So you have a circle on y-axis. So now you have a cylinder over here, because once you have a circle, you draw the cylinder, and from the top it is cutting by this plane, z equal to 4 minus y. So what is z equal to 4 minus y in yz plane? It's a line, right? In yz plane, it's a line passing through 4 and 4. So if this is 4 and here suppose at the top, this is 4. So it's a line like this. And a line becomes a plane in 3-dimensional space. So you have something like this. So you have a cylinder, but you are chopping it out. You are chopping it out with this plane. So this is the curved part you have. So you have to find this volume above this circle and below this circle. So this is the volume you need to find. Good. So now we have the region. Now it is good. Now it is easy to find the limits. Now how will you find the limits? To find the limits of z, you draw the line parallel to z-axis. It is entering from the base of the circle, which is in xy plane. So z is starting from 0, coming out from this plane. So your z is starting from 0, coming out from 4 minus y, but y is nothing but r sin theta. Okay, good. Now what is your r and theta? So you project in xy plane. When you project in xy plane, what do you get? You get this circle over here, right? So the projection is nothing but this circle over here. Now what are the limits for this? So first, to find the limits of r, what you do, you draw these radial lines, right? You draw the radial lines. From where it is starting from origin, and origin is in the domain. So your r is starting from 0 and it is coming out from these points. And what is this? This is nothing but r equal to 2 sin theta. So this is nothing but r equal to 2 sin theta. And what is your theta? So if you want, you can draw this in xy plane for simplicity. So this was my y-axis, this is my x-axis. Circle is over here. This is 1, this is 2, with center is 0, 1. So as you can see, my theta is going from 0 to pi. Okay, not 0 to 2 pi. We are in first and the second quadrant. So theta is 0 to pi. You solve this, you get an answer. So the first homework for today's session is you have to comment the answer for this question. You have to tell me what is the volume. Okay, so that's the first thing. Now let me give you one more. So if you observe, when it was sin theta, we had y upon r, and therefore the circle was here on y-axis. Let me give you one more homework example. So this is the first one. The second homework I would like to give you is, take this to be 2 cos theta. Okay, and take this to be 4 minus x. Now we do the same thing. You try to sketch the region. Now here you are having cos theta, so you will have x upon r, and therefore the center now will lie on x-axis. Your center will lie on x-axis, so you will have a circle over here. You try to draw this and you will have something cut over here. So you will get this as the volume. I mean, this is the region surface you get whose volume you need to find. Okay, so try to tell me the answer for this question. So this is your second homework question. The first one is the answer for the previous one. The second is the answer for this one. So when you have only sin theta, center is on y-axis. When you have only cos theta, center is on x-axis. Third homework. When you have the expression involving sin theta and cos theta both, what do you think? Where your center will lie? Will it be on x-axis, y-axis, or any of the quadrants? First, second, third, fourth. So these are the 3 homework questions till now I have given you. So make sure you pause the video and answer these 3 questions and then proceed. So here is the last example. So this is the question and we need to solve this in the order dz, dr, d theta. Okay, so r cube as it is, I need to solve in this order. So first of all, I should know what is the region, right? So that then only I can do the change of order. See, change of order is usually difficult in cylindrical and spherical. So we avoid using that, but then one should have the idea. Okay, so now here, now see what we have. We have theta from 0 to 2 pi, 0 less equal theta less equal 2 pi. Your z is from 0 to 3. So I know the height is 3 and it is in the upper part of the surface. Okay, not in the bottom part. Okay, and what is your r? It is starting from 0, z by 3, 0 less equal r less equal z by 3. Okay, so you have something over here in 3-dimensional space, x, y and z over here. Now what is r? R is starting from 0. So okay, and so that means it is starting from here somewhere, because z axis, this is my axis of cylinder. Okay, and what is your z? So r equal to what? It is going till z by 3. So this implies what is your z? 3r. What is this? 3 square root of x square plus y square. What is this? This is nothing but a cone, the standard equation of cone, right? So you draw this cone over here. So this is the surface you have. What is the height? Your height is nothing but 3. It is going till z is going from 0 to 3. So z is going from 0 to 3, and your r, as you can see, this is, as I told you earlier, this is your r, starting from 0 going till here. And what is this? This is nothing but z equal to 3r. So r is nothing but z by 3. So this is the surface you have. And now you have to do the change of order. Z, what are the limits of z? You draw the line parallel to z axis. So it is entering from cone. What is the cone ka equation? Z equal to 3r. And what is the height? Height is 3. Now when you project this on xy plane, you have to tell me what is r and theta. So when you project, what is this? Z equal to 3, right? So when you put z equal to 3 over here, 3 gets cancelled. You have x square plus y square equal to 1. So your r is going from 0 to 1. Theta will go from 0 to 2 pi. And now what you can do is you can solve in either of the order you want. And if you try to solve this, what answer you get? So we can think of solving, not a big deal. R cube, what is this? 3 minus 3r dr d theta, right? R and theta. So for theta I will have 2 pi. And what is the integration of r? 3. What is this? R raised to 4 upon 4 minus 3 r raised to 5 upon 5, 0 to 1. So this is your 2 pi. 3 will come outside. 1 by 4 minus 1 by 5, which is pi into 3 upon 10. 3 pi by 10 is the answer. I hope my calculations are correct. 120. Yeah, so 3 pi by 10 is the answer. You can solve by this, or you can solve this as well, so that you will come to know whether the answer is correct or not. Answer should come out to be same thanks to Fibonacci theorem. Okay, so that's how you do the change of order in cylindrical. Now let me give you one more homework problem and then we will stop. So this is the fourth example you need to solve. So d theta, dr, dz. So theta is 0 to 2 pi, r is 0 to root z, and z is 0 to 1. So you have to solve this in the order. The question is, you need to solve this in the order dz, dr, d theta. So you tell me what are the limits in this order and the answer. So limits and the answer. So that's the fourth problem for you. So I hope you have got the good overview of cylindrical coordinate system. If yes, do not forget to like, subscribe and share. Thank you.